Hello friends, welcome to our channel Knowledge Amplifier, and today in this particular video I am going to discuss how we can simulate data with specific correlation. Okay, so already in my previous video I discussed in detail about the concept of correlation, what is its significance, how to compute correlation mathematically and programmatically, both I have discussed, right? Now suppose you have to generate two data set which is having a specific correlation, suppose rho, and then the problem statement is how we can generate the data. That is what I am going to discuss in this video. Okay, because this kind of data set generation which is having a specific correlation value can be helpful in some other statistical analysis which you can perform on that data set. Okay, so for that let us start with some random data set. So at least to get the correlation in between two data set, we require at least two different sets of data, right? So I am starting with two uncorrelated random variables x1 and x2, and how to generate uncorrelated random variable? That is very simple. We can use randn, right? Because randn will generate Gaussian distribution. Okay, so one particular random variable which is having Gaussian distribution with zero mean and standard deviation having value 1 will be having almost zero correlation with respect to other randn Gaussian distribution, right? So we will basically start with our randn, and from this uncorrelated random variable we will try to make some correlation or make some data set which is having a specific correlation, which is rho. Okay, so what we will do, we will basically try to generate another random variable z with some specific amount of coefficients and linear combination of these two random variables, such that with this z random variable, if we try to calculate the correlation value with x1, which is one random variable of our data set. Okay, so when you try to compute the correlation in between z and x1, that is two random variable data set, you will be getting the specific correlation value rho. Now the problem statement is, in this linear combination we need to find out alpha and beta value. Okay, so z equal to alpha x1 plus beta x2. Okay, so from the intuition itself we can say one coefficient should be rho. Okay, because you can understand that this is nothing but kind of slope. So if rho increases, that means the linear term of z and x, or linear relationship of z and x, will increase. If rho decreases, that means linear relationship between z and x1 will decrease. That means in the correlation and in the slope part, obviously as we know that there are certain amount of similarity present. So from the intuition itself we can say that if we want to make the z such that z and x1 will be having a specific correlation rho, then we can simply try to put the alpha value as rho. Okay, because the slope part and the correlation will be having certain similarity, which we have discussed in our previous video also. So one particular coefficient from intuition itself we can derive, that is rho. But what about the beta? That's what we are going to discuss. Okay, so the equation which we are having, that is nothing but correlation of z with respect to x1. So z is a random variable set, x1 is another random variable set. Among these two the correlation should be rho. That's what I have written here, correlation of alpha x1 plus beta x2, which is linear combination of x1 and x2, two different uncorrelated random variable, that is nothing but z only, and correlation of z with respect to x1 should be rho. Okay, now what is the formula? You just put there. Okay, that is correlation of x comma y is nothing but covariance of x comma y by square root of variance of x multiplied by variance of y. That's what we have just put here. Rho equal to covariance of, so our x is this particular one, alpha x1 plus beta x2 comma x1 by standard deviation we are multiplying in the denominator. Okay, that is square root of variance. Okay, is nothing but standard deviation. So that's what we have written here. Okay, that is square root of variance of alpha x1 plus beta x2 multiplied by variance of x1. Okay, now in this numerator we can apply this particular formula, that is covariance of x plus y comma z equal to covariance of x comma z plus covariance of y comma z. If you apply the same, you will be getting this particular one. So alpha x1 you can consider as x, beta x2 you can consider as y, and apply this formula, you will be getting this one. That is rho equal to covariance of alpha x1 x1 plus covariance of beta x2 x1 by square root of this particular term. So here what we did, if you see, variance of x plus y, that is nothing but variance of x plus variance of y. So that's what we just splitted this particular one term into two, that is variance of alpha x1 plus variance of beta x2 whole multiplied by variance of x1. Okay. Now if you see this particular term, covariance of alpha x1 x1, alpha is a constant, it will come outside, and covariance of x1 x1, that is nothing but variance of x1, right? So we know from the fundamental concept of statistics that covariance of one variable with itself is nothing but the variance. So we can write here alpha of variance of x1 plus of, see, covariance of beta x2 x1. So beta will come outside. So we have kept here beta and then multiplied by covariance of x2 x1. Okay, right? And what we are doing in the denominator, if you see variance of alpha x1, so if you take alpha outside, so variance of ax is nothing but a square variance of x. So the constant term, when it will come outside, it will be squared. Okay, so here we are getting alpha square variance of x1. Okay, plus similarly here beta we just take outside, we will be getting beta square variance of x2 whole multiplied by variance of x1. Okay, now see this particular term, covariance of x2 x1. So already I discussed that x1 and x2 are uncorrelated random variables, so their covariance will also be 0, right? So just put here and this particular term will become 0, and what we can do, we can just make whole term inside square root, that is both numerator and denominator, just keeping alpha outside. And if we do that, we will be getting this one, that is rho equal to, only alpha is present outside, square root of this particular variance of x1, when it will come inside square root, it will be variance of x1 whole square by alpha square variance of x1 plus beta square variance of x2 multiplied by variance of x1. Now see, variance of x1 here in the denominator, in the numerator variance of x1 whole square. So you can just simplify this, and only variance of x1 will be remaining in the numerator. Okay, and in the denominator we will be getting this one. Okay, so rho equal to alpha multiplied by square root of variance of x1 by alpha square variance of x1 plus beta square variance of x2. Okay, right? Now if you see that initially x1 and x2, how we tried to generate with randn. Okay, so randn will generate same standard deviation, that is standard deviation 1, such data it will generate, right? That is variance of x1 equal to variance of x2 equal to nothing but 1. So what we can do, instead of in this particular equation, if you see we were here, now instead of variance of x2 we can put variance of x1, because variance of x1 is nothing but variance of x2, that is nothing but 1, because randn will generate all data having standard deviation as 1, that means variance is 1. Okay, so variance of x1 equal to variance of x2, so we can just simply substitute here and we are getting this particular one. Now you can see in the numerator variance of x1 is present, and in the denominator you can take common variance of x1, so they will cancel each other and you will be getting this particular term, that is rho equal to alpha multiplied by square root of 1 by alpha square plus beta square. If you just do cross multiplication, you will be getting rho multiplied by square root of alpha square plus beta square equal to alpha. Okay, now from the intuition we got our value alpha as rho only. Okay, so substitute here. Now our aim will be computing the beta value. So rho square root of rho square plus beta square equal to rho. Rho will cancel each other, so we will be getting root over of rho square plus beta square equal to 1. So beta square equal to 1 minus rho square. So beta is nothing but root over of 1 minus rho square. Okay, so we got our alpha value, we got our beta value. So the assumption is our z variable, if we define like this way, rho multiplied by x1 plus root over of 1 minus rho square multiplied by x2, then the correlation in between z and x1 will be rho. Okay, where x1 and x2 are random variable which are uncorrelated, that we are generating using randn function, right? So this is what is the equation using which you can generate two data set which is having specific correlation value. Okay, all you need to do, you need to first choose two uncorrelated data using randn x1 and x2. Then you need to create the z random variable, which is nothing but generated how? That is correlation coefficient what we want, that is the target correlation coefficient, that is rho multiplied by x1 plus root over of 1 minus rho square multiplied by x2. Okay, so this is what is the mathematical intuition. I tried to make the derivation simple because there are a lot of assumptions and boundary conditions to be applied on this particular optimization problem, which I am not discussing in that detail. So I hope the intuition part is clear to you. Now let us go to MATLAB and let us see whether it is actually happening or not. So what we'll do, CLC, clear all, close all, warning off. As we generally write, CLC is basically used to clear the command window, clear all is basically used to clear all the previously used variables. Close all is basically used to close the existing opened figure window, and warning off is basically used to suppress any warning. Okay, now suppose I want to generate 1000 number data points, and our target correlation coefficient is suppose 0.6. Okay, so first will be, I'll be creating x1 equal to randn 1 comma n. So I have created, sorry, this will be randn. Okay, so we have generated our first uncorrelated random variable, and second will be x2 equal to same. Okay, so let us see whether they are really uncorrelated or not. All we need to do, just run this particular piece of code, and then here we can write corr of x1. So we need to give us column vector, so I am transposing, and see 0.0059, that is almost zero correlation is present in between these two variables x1 and x2. So that is, they are uncorrelated, their mean is 0, their standard deviation is 1. That's what the random property is. Now we will create another set of random variable z equal to rho multiplied by x1 plus square root of 1 minus rho square multiplied by x2. Okay, so this is generating our that random variable z, which if we calculate the correlation with respect to x1, we should get the correlation value as 0.6. Okay, we'll test it. So what we'll do, next tile we can give, and then here let us do scatter plot first. So scatter plot x1 comma x2, and I want this scatter plot with all filled circles. Okay, and then here another next tile. Okay, I will be simply copying this. Okay, and then here I'll be writing x1 and z. So this one should be having certain amount of correlation, but these data should be completely uncorrelated. Okay, I can write here disp corr of x1 comma x2. Similarly, so this will display the correlation between x1 and x2, which is 0, almost 0 we have seen, and this particular correlation with x1 and z, which should be approximately 0.6, that is our desired correlation. Okay, so let us run this particular piece of code and let us see. Okay, sorry, I think I have not given this here transpose. I should be giving transpose here. Now let us run this particular piece of code. Okay, here also transpose should be given, because correlation expect that column vector. So you will see that this is our x1 and x2. From the scatter plot itself, you can understand that there is not at all a single amount of correlation. There is no relationship, no linear relationship present. But if you see this one, if I just make this particular bigger, you can see that in between z variable and x1 variable, there is a slope present. If x1 is increasing, z is increasing. If x1 is decreasing, z is decreasing. That means correlation present. And what is that value? If you see here, 0.6173. Almost close to our desired correlation, which is 0.6. Okay, so this is how, using this simple equation, we can generate two data set which is having a specific correlation for our requirement. I hope you have understood this. enjoyed this. If you find this video helpful, then please like, share and comment. Subscribe our channel if you haven't subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you.